Welcome back to The Drop, where we're going to connect some wildly different dots across the bleeding edge of AI right now. Today, we're diving into a massive shift that's happening right under our noses. For the last couple of years, everyone has been, completely obsessed with raw model power, right? We've all chased parameter counts, training data, and base capabilities. But looking at 5 brand new disparate developments across the tech landscape today, it's clear the era of the raw model is evolving into something way more practical. We're officially entering the era of AI systems. Here's our roadmap for this drop. We'll start with the AI systems era, then look at how natural language meets music, check out some harnesses and video pipelines, connect agents to actual workflows, and finally wrap up with extreme on-device efficiency before our conclusion. All right, let's jump right into section 1, the AI systems era. So, it's a pretty provocative question, isn't it? Is the era of the raw foundation model actually over? Well, the short answer is no. Obviously, models are still the engines, but, and this is a big but, the longest, most impressive leaps in AI performance right now aren't coming from simply making that engine bigger. They're coming from how we build the car around the engine. And that brings us to a crucial concept, the harness. Think of the harness as the surrounding system. It's basically the scaffolding. If a language model is a brain, the harness gives it the rest of the tools. It gives it memory, hands, a feedback loop, maybe even a supervisor. As we'll see today, the harness dictates exactly how an AI receives context, uses its tools, maintains its state, and crucially, how it sustains progress over really long-running tasks. This is the anchor concept for everything we're exploring today. Moving on to section 2, natural language meets music. Now, Alibaba's Happy Shrimp 1.0 brilliantly illustrates this shift. The old way of AI music generation basically forced you to act like an audio engineer. You had to painstakingly stack all these technical tags like lo-fi, R&B, or 808 drum patterns. But the new way changes the interface entirely. It treats music as a special language with its own grammar and semantics. Because it uses this end-to-end natural language system, you totally avoid those misaligned lyrics and clunky transitions you'd normally get when you clumsily bolt different generation modules together. Just look at this exact prompt from one of their test cases. A user literally just typed monologue of a ghost being abandoned. That's the whole prompt. No tempo markers, no genre tags, but the system autonomously designed the entire structure. It set this eerie organ atmosphere, brought in a slow storytelling male vocal, and built up to a perfect emotional climax. The system actually understood the intent rather than just checking off a rigid list of technical requirements. It's a total game changer. All right, section 3, harnesses and video pipelines. Okay, prepare to have your mind blown a little bit by this data. The ARC AGI 3 benchmark is notoriously brutal. It drops an AI into game-like environments with 0 instructions, forcing it to figure out the rules on the fly. When evaluated as a raw model, Anthropic's Claude Opus 5 scores about 30%. Not bad. But look at that second result. Nvidia wrapped that exact same Claude model in their new AVO harness. That stands for Agentic Variation Operators, and it scored a literal perfect 100 on the public set. 83 levels fully solved. They didn't change the model at all, just the harness. So how on earth is a 70-point jump even possible? Well, the AVO harness gives the model persistent memory, allowing it to remember what worked and what completely failed. It also adds a supervisor, a separate system that watches the main agent and actively redirects it if it gets stuck in an unproductive loop. Actually, before absolutely crushing the ARC benchmark, Nvidia let this setup run completely autonomously for 7 straight days, just optimizing GPU kernels. It explored 500 different directions and ended up producing kernels that outperformed existing human-engineered standards by up to 10.5%. The model is just the brain, but the harness is what lets it do a full week of engineering work on its own. We're seeing this system's approach completely reinvent video generation too. Bytedance just open-sourced Bernini diffusers v2. Instead of just begging a model to spit out raw video frames from a text prompt, Bernini uses a really strict step-by-step pipeline. First, a semantic planner breaks your complex request down into an explicit plan. Then that plan gets passed to a diffusion decoder, and finally, it's rendered into video. This latent semantic planning means the system can handle super complex, multi-step editing requests, because it's systematically thinking through the steps before it starts drawing. Let's move into Section 4, Connecting Agents to Workflows. Enter ComfyMCP. If you've ever used ComfyUI for generating AI media, you know exactly how complex those node-based workflows can get. Well, ComfyMCP uses the Model Context Protocol to connect an AI agent like Claude, or a coding agent directly to your local or cloud ComfyUI setup. You literally just chat with your agent in plain English, and it operates the complex software for you. This standard operating flow perfectly shows the power of giving agents real-world hands. Say you ask, generate an image of a cat astronaut. Step 1. The agent actively searches your system to discover the right tools, templates, and models. Step 2. It runs the generation by submitting the workflow API call. And Step 3. It retrieves the output and just hands you a download link. The agent was given a harness that essentially transforms it into your own highly skilled personal software operator. Now for Section 5, Extreme On-Device Efficiency. 0.1 billion, that's 100 million parameters. In a world where frontier models have hundreds of billions, or literally trillions of parameters, 0.1b is almost unfathomably tiny. Yet this is the size of the language decoder in the brand new Audio 8 ASR model. It's a speech recognition tool that runs completely offline, directly on your phone, and supports 7 different languages. To understand how they pulled this off, let me look at the architecture. They didn't just try to train a tiny model from scratch. No, they built a smart system. They took a proven, robust audio encoder from a larger model. So they basically reused a really great set of ears. Then they completely separated that from the brain or the language decoder, which is that ultra-lightweight 104 million parameter piece. The total system ends up being just about 324 million parameters, making it lightning fast and entirely offline. But wait, how does a brain that small actually stay accurate? It's all thanks to a training system called on-policy distillation. Basically, the tiny student model tries to transcribe the audio. Then, a massive, super powerful teacher model steps in and scores the top candidates, focusing only on the specific words the student struggled with in real time. Finally, the student corrects its logic based on that feedback. Instead of just rote memorization, the small model actively borrows the massive teacher's perspective right exactly where it gets confused. And they added one more brilliant piece to this: hot word boosting. We all know small models famously struggle with niche proper nouns, like maybe your specific company's name. But instead of forcing you to fine-tune the whole model, which is a nightmare on edge devices, the system just lets you input a text list of proper nouns at runtime. The system artificially adds points or adjusts logits for those specific words as it generates text. This solves a major edge computing hurdle, keeping the model totally lightweight but highly customized to exactly what you need. And that brings us to Section 6, the conclusion. We are now firmly in the systems paradigm. As we saw with Happy Shrimp, intuitive natural language interfaces are entirely replacing rigid, complex tags. As Nvidia proved with their AVO harness, wrapping a model in robust memory and a supervisor can take reasoning from a 30% score all the way to a perfect 100. With tools like ComfyMCP, AI agents are finally stepping out of the chat box to directly operate our workflows. And through clever pipelines and distillation systems like Audio 8, we are bringing highly capable AI straight to our edge devices. Which leaves us with this final, absolutely crucial thought. We spend so much of our time arguing about which base model is a few percentage points smarter than the rest. But if simply changing the harness can radically transform a model's capabilities to this degree, the real question isn't just which AI you're using. It's this: what system are you building around your AI today? Thanks so much for joining me on this drop. I'm Aladdin, and I will catch you in the next one.